Hello students, today we will talk about problem space and search. It's an important topic. Let's start with problem space. What is problem space? Problem space is the environment or the map where actually we are trying to solve a problem. Search is the process of navigating that map to find an answer. Search is the algorithmic process an AI uses to explore the problem space, which means there is a systematic way which search follows to find the goal. Okay, now there are four components in problem space. One is initial state, the starting point of the problem. Second is the goal state. Where is the end point or solution? Third is actions or operators. What are the rules that are allowed and how it will change from one state to another state? What you will have to understand is in a problem space, it is split into multiple states. Okay, say 10 states where the algorithm, search algorithm, moves from one state to another state until it finds the right solution for us. Fourth is the constraints or restrictions. These are the limitations that must be adhered to while navigating the space. Hope you understand. Okay. Okay. What is search? Search is the algorithmic process. I just mentioned it before to explore the problem space. See, AI cannot magically guess the right sequence or right path to find an answer. So, what it does is it systematically generate and evaluate series of states, a set of states, until starts from it goes from start to finish. Okay. Now here what are the types are there in search? Two types are there. One is uninformed search, which is a blind search. Second is informed search or heuristic search. Okay. There are two types in uninformed search. One is breadth first and depth first. Breadth first is nothing but it'll start searching like this in horizontal way. Depth first is it'll start searching vertically. This is DFS and BFS. Okay, so what are the characteristics? A has no information about the problem space other than the rules of the game. It doesn't know if it has got closer to the goal or not. It just tries systematically. It follows the process. That is all. Okay. Second is informed search. Here we have greedy best first and A star. Actually, these two are only used, and we have two videos, one for each greedy first best first search and A star algorithm search. So if you want detailed explanation, it is there in those videos. Okay. Now this informed search is it uses a heuristic function, an educated guess, and pick up the most promising path. It uses a function and the formula is G plus H. Okay, you will understand it as we talk. Okay, next is defining a problem as a state space search. Okay, here the real world problem, to make a real world problem solvable by an AI. Okay, the problem is from home to university. Okay, the goal is university, starting point is home. Okay, now this is where it is important. A software engineer must formally translate it to a structured state space. See, real world problem is starting from home, going to university, attend classes. Okay, simple, right? This is a real world problem. Now, this has to be translated into multiple states and data structure. Using data structure, what will happen is it has been converted to home, bank, police station, garden, school. Multiple states are brought in. It might look very simple for you, stating that, okay, what is a big deal from going from home to university? No, this is a simple example I've given you for you to understand. Assume an Amazon wants to deliver its products to its customers. Minimum of in India every day, every city there will be 1 lakh deliveries. Okay, what will happen then? The route has to be very optimal, right? And it is going to cost heavily if the path is not right. Okay, and third is time issues are there. So it is not as simple as going from home to university. If we want to deliver 1 lakh products in one city, the city where you are living in, then it becomes very, very complicated, right? So, in such cases, there has to be a way. Okay, now let's hope you understand the complexity. Now, the state representation. The problem state should be converted to data structure. Now, Amazon 1 lakh delivery has to be converted into multiple areas, streets, and such, so that the 1 lakh deliveries happen on one day. Okay, so the initial state, here the initial state is home. Amazon, it is the warehouse, Amazon warehouse. Okay, and the configuration data structure at the very beginning of the program. It should have the exact map, exact number of products that should be delivered today. Okay, that is the initial state. Then the actions that are there. Okay, what are the valid operations that can happen? If we look at our example, we have from home, you can go to bank, garden, school. Our goal is university, but we have only 3 ways out of that home. So these are the actions that are available. Okay, next is goal test. Every point we'll have to check. When we reach bank, we'll have to check whether we have reached the goal. Okay, A, we know that it is bank, but A has to cross verify whether the goal has reached. Next is path cost. See, path cost formula I just told you. F is equal to G plus H, heuristic value. That is the G plus H. Okay, here what you need to understand is, for 1 lakh products, if you keep on going up and down, the cost is going to be very, very expensive. So the optimal path has to be figured out, and the product has to be delivered so that it is cost effective for the company. This is where AI comes in. Okay, okay, now what are the issues that we will face in design of a search problem? Okay, here, state space complexity. State space complexity is, as I said earlier, for complex problems, number of possible states and path grows exponentially, which means for 1 lakh products delivery, if we multiply, go up from here, go here, then come here. So if we keep on juggling, the cost will increase. And say for another example is like breadth first search. in a library, what breadth first does is it does horizontally. If you are searching for a book in ground floor, first floor, second floor, without knowing which section you have to look for a book, for a AI book, you keep on looking from ground floor, first floor, it's going to be taking a lot of time. So it is not an effective way. That's what the point number one is saying. Second is heuristic design and evaluation. Here, these algorithm A star and best first search, what it does is they use heuristic design, which is this one, heuristic value and the path value. Here it will be very cost effective. Okay, this is using A star algorithm, search A star search algorithm uses heuristic design. Third issue is suboptimal solution. What it does is, this one is, we always, it uses a local optima. What it means is, see, you would have seen this in chat gpt or gemini. You will ask something and it will keep on repeating this, it will keep on giving the same answer. What it does is it gets trapped in the local optimum and misses the better answer completely. Okay, this is the third one. Fourth one is dynamic and uncertain environments. Many real world problems like chemical factory, what happens is the environment is unpredictable, like temperature, chemical mixture, external factors are there, right? So what happens is the environment changes dynamically. So to reach the goal, it has to be continuously monitoring. So these has to be considered. These are the issues in design of search programs. Okay. So hope you understand. If you have any doubts, please ask me. I'll try to explain. And you want to know A star algorithm, best first search algorithm, separate videos are there where you can look. Okay. All the best, students.